So hello everyone, welcome to the lesson of linear transformation. We are considering here linear transformation. Linear transformation, also known as linear mapping. This is a transformation from one vector space to another vector space, particularly applicable to those vectors that preserves linearity property. This is the basic definition. A mapping T from vector space U to V, this is called linear transformation of vector space U to vector space V. If sum of vectors and applying the transformation gives us this. For all these vectors U and V belongs to U. Similarly, for scalar multiplication and applying this transformation gives us this one. Jointly we can say transformation on AU plus BB equals to ATU plus BTV. For all AB belongs to field and for all UV belongs to vector. For these E vectors belongs to U. Linear transformation transforming the vectors and will not receive the same kind of vectors. This is the transformation, or this is a mapping. Vectors in Rn to the vectors in Rm. This is n tuple of vectors, m tuple of vectors. And for linear transformation, well-defined. For well-defined, we will show 1, 1 and 1, 2. Here we will check whether the mapping T R3 to R2 and transformation defined by T x y z equals to z x plus y. This is a linear transformation or not. This is the domain element and this contains R3, 3 space, 2, 2 space. Therefore, this vector can take vectors of length 3 and then transforming to vectors of length 2. Like this transformation on applying these 3 vectors, they are transforming up to 2. So this vector can take vectors of length maximum 3. Now let us consider U equals to x1, y1, z1. 1, 2, 3. Another vector V equals to x2, y2, z2. Where these vectors U and V are of length 3 and components 1, 2, 3. These are components of these vectors. These are components of this vector V. Now, property 1 says that sum of vectors U plus V, this coordinate will be added by this one. This will be this one. So U plus V, x1 plus y1, this is x1 plus x2, y1 plus y2, and z1 plus z2. And we can say if k is any scalar belonging to the field, so this gives us k x1, k y1, k z1. Now applying the transformation T u plus v, as we have discussed first property of linear transformation sum of vectors, so u plus b equals to transformation x1 plus x2 now transformation applying this one, because this is the basic definition, z comma x plus y. Therefore this will be z. This is the z term we can suppose, so we can put here z1 plus z2 comma x plus y. This is this term plus this term. From this equation we will obtain this one. We can separate the terms. We will obtain z1 comma x1 plus y1, x1 plus y1 plus z2 comma x2 plus y2. By this definition, txyz is zxy, zxy. So we can see this one as, because we have considered x1, y1, z1, x1, y1, z1, these are the terms of this u vector. So we can say this is the transformation u. If we apply this transformation, we will get these terms like that. Here we will obtain this term like that. Similarly, we can say this is TV. Now, or we can write here also, transformation on KU gives us KZ comma kx plus y. So we can write kx plus ky by this definition. We can write here kz comma x plus y. This is same as this term. So we can consider this one as u. So we can say this is k tu. Therefore k is the scalar. Belonging to field. Since transformation on ku is ktu and transformation summation of vectors gives us separated transformation of vectors. This property holds true, this property holds true. Both properties of linear transformation are satisfied here. So we can say this transformation R3 to R2 space defined by this one is a linear transformation. And there are so many applications of linear transformations: rotating coordinate system, shifting coordinate system, stretching, and many more applications of linear transformations. And these are some questions one can solve easily based on linear transformation. This is question number 1. Transformation goes from 2 space to 3 space, defined by this one. This is linear transformation or not. One can apply both the property, and this is the answer. This is a linear transformation. Second question, for transformation R2 R2. Defined by dx equals to this one, 3x 5x. Find the matrix representation. So one can solve easily and obtain the matrix equals to 3 5. You can solve easily. If facing some problem, you can comment or you may discuss with us, so that we will provide you the detailed solution. And if you want to take notifications of these videos, you can subscribe for further notifications and many more. Thanks for watching and giving your valuable time.